So we're looking still at rational functions, and we want to look at x-intercepts. How do you find the x-intercepts of a rational function? So when we look at functions in general, remember the idea is you basically take your function, right, set it equal to 0, and your solutions will be the x-intercepts, also called the zeros or the roots, right? So a number, x equals c, is an x-intercept, or a root or a 0 if x equals c is the solution to that. Now, rather than taking our entire rational functions and setting them equal to 0 and trying to solve for x, there's something much simpler you can do, and that's what we want to discuss. So how do you find x-intercepts for rational functions? What's the quick way to do it? So let's say you have a rational function r of x, and let's say on top you have x minus c as a factor, the times a polynomial, and then on bottom you have a polynomial. And let's say this entire expression is reduced. You can't cancel out anything between the top and the bottom. That means that r has an x-intercept at c. So basically what you're doing, you're just focusing on the top. You're just focusing on the top, and you're just looking at factoring the top. So you want to factor the top and the factors. And you basically set your factors equal to 0 and solve. And that'll give you all your x-intercepts. Yeah. So it's a pretty simple thing to do here. So just some example here. Find the x-intercepts of some rational functions. Say I have x squared minus 3x minus 54 on top, and on bottom we have x squared plus 8x plus 16. And we're just trying to find the x-intercepts. Or I might call them the zeros, if you want to call them the zeros, or the roots. All means the same thing. So all you do, you focus on your top here. Factor your top. So you factor the top. We'll just leave the bottom alone. We're not going to factor the bottom here because we're not focusing on factoring the bottom right now. We'll just leave it alone. Normally, you would factor the bottom, though, for finding the vertical asymptotes, right? But for the factors of the top are going to tell you the x-intercept. So I can put an x here, and I want to find two numbers that multiply to give minus 54, right, and add to give negative 3, and I come up with like negative 9 and positive 6. So then I take my factors up top, and I set them equal to 0. I get 9 as an x-intercept, and I get negative 6 as an x-intercept. Okay? Let's do another. Sometimes you'll be fortunate enough to have them already factored for you. Sometimes you'll see something like this: 5x minus 3 to the 4th power, x plus 8 to the 2nd power, and on the bottom you'll have some stuff. 10 times x plus 1 to the 3rd, x minus 7 to the 4th. So in this case, it's already factored for you, right? This is already in factored form. So if I want to find the x-intercepts here, I don't even have to do any factoring myself. I'm just going to take this factor here of x minus 3 on top and set that equal to 0. And this factor here of x plus 8 on top, and set that equal to 0. So I'll get x equals 3 as an x-intercept, and x equals negative 8 as an x-intercept. So we're not going to do anything with the bottom right now, right? The bottoms, those would tell you the vertical asymptotes. Okay. Now, as far as finding y-intercepts, that doesn't change at all. So y-intercepts, let's remember how to find y-intercepts, finding y-intercepts of a function. well, finding the y-intercept of a function. There's just going to be one y-intercept of a function. Basically, you just set your x equal to 0 and solve for y. So we'll say y equals b is the y-intercept for the function f if f of 0 equals b. Well, basically, you plug in 0 in for x, plug in 0 in for x, and your output b is going to be your y-intercept. So that's not changing here. There's nothing special about rational functions that you need to do. So we'll still be doing y-intercepts using this. Okay, so what we want to start doing, we want to start finding all these different things together. We want to do the vertical asymptotes, the horizontal asymptotes, the x-intercepts, and the y-intercepts. Everything all together. Putting everything all together. That's the goal. Okay, so I'm just going to do some exercises. Instructions are to determine one vertical asymptotes, the horizontal or slant asymptote, three x-intercepts, and 4 the y-intercept. Okay, so this is what we need to do. Let's call this A, B, C, and D. I like that better. A, B, C, and D. All right, so number 1, here we go. Number 1, we have a function r of x equals 3x times x plus 4. That's the top polynomial. And the bottom polynomial is going to be oh, I copied this down wrong. I copied it down wrong. My bad. Copying down stuff wrong. That's not good. Okay. Copied it down wrong. Let's try this again. We got x minus 2 on top, and on bottom we have x squared minus 25. No, that's the wrong one. I don't want to do that one. Let's just do something else. Let's do something else. Wrong problems are not good. I'm having trouble reading this here. Okay, here we go. We got x squared plus x minus 2. Okay, and on bottom we have x squared minus x minus 2. Okay, so the first thing we want to do is vertical asymptotes. Before I even start finding any vertical asymptotes, what I'm going to do, I'm going to factor my top and factor my bottom. So on top, I'm going to make two pairs of parentheses. X times x to give me x squared. I'm going to find two numbers that multiply to give me -2 and add to give me a positive 1 right here. So those numbers would be, let's see, +2 and -1, right? 2 times -1 is -2, 2 plus -1 is +1. And on bottom, I'm going to do my factorization as well. I'm going to make two pairs of parentheses. I'm going to put an x times an x to get x squared. And I'm going to find two numbers that multiply to give me -2 and add to give me -1 right there. So what two numbers do that? That would be -2 and +1. Now if I could reduce anything here I would, but nothing reduces. Nothing cancels out between the top and the bottom. So for finding vertical asymptotes, that's what we're going to do next. We're going to take the bottom factors, those are the red factors, and set them equal to 0. And I solve first by adding 2 to both sides. I get x equals 2 as a vertical asymptote. The second one, when I subtract 1, I get x equals -1 as a vertical asymptote. Okay, so what do we do next? B. Horizontal or slant asymptote. Well, we're not going to have a slant asymptote. We're going to have a horizontal asymptote here. And we know that because if you take the degree of the top and the degree of the bottom and compare the degrees are the same. So since the degree of the top, I'll call it f of x, equals 2, and that's equal to the degree of the bottom, we'll call the bottom one g of x, then there's a horizontal asymptote. Where at y equals, so remember when they have the same degree on top and bottom, you're going to take the leading coefficients. So I'm going to take a leading coefficient of 1, a leading coefficient of 1, and take their ratio. So 1 over 1. So y equals, what's 1 over 1? 1 over 1 is 1. So there's a horizontal asymptote at y equals 1. What else do we want to do? We want to do the x-intercepts. See? So to find x-intercepts, I'm going to take my factors on top and set them equal to 0. So I'm going to take x-intercepts. Take my blue factors and set them equal to 0. I solve those for x. I'm going to get -2 for the first one by subtracting 2 from both sides and adding 1 to both sides. On the second one, I'm going to get 1. X equals 1. Okay, so finally we have to do the y-intercept. So to find the y-intercept, I'll plug in 0 for all my x values. So I'm not going to use the original form. I'm going to use the factored form for this. You can use whichever form. You can use the original form of the rational function, or you can use the factored form, but I'm going to use the factored form. I kind of like doing that. So what we do, we're going to basically set x equal to 0 everywhere. So everywhere we have an x, we're going to plug in a 0 into the function. And we're going to call it y rather than r of x. We're going to call it y. So let's see what that does. That does, so you're going to have 0 plus 2 is 2. 0 minus 1 is -1. On bottom, 0 minus 2 is -2. And I wrote something down wrong. didn't I? That should be a 1. I missed something on bottom. That should be a 1 right there, right? Right, that's a 1 when we factored right there. So that's going to be -2 times 0 plus 1 on bottom is 1. If you clean that up, you're going to get, let's see, 2 times -1 on top is -2, and on bottom, -2 times 1 is -2. So you're going to have a y-intercept that -2 over -2 is +1. So interestingly, your horizontal asymptote is at y equals 1, and your y-intercept is at y equals 1, interestingly. So, yeah, you're going to have a y-intercept along your horizontal asymptote. Now, as far as graphing this, we're not going to quite worry about that now. We'll maybe have a look at the graph of this later in the next section. All right, number 2. What do we have? R of x equals 3x squared plus 12x over x squared minus 1. So we have to find all these different things. Before we even start finding different things, though, let's factor the top and let's factor the bottom. So in the top, I can take out a common factor, a greatest common factor of 3x, right? There's a 3x in common. And I'm going to put a parentheses, and I got to figure out what times 3x is going to give me 3x squared plus 12x. Well, that's going to be x plus 4. And I go to the bottom, and that's a difference of squares. Right, you have x squared minus 1 squared, so I can do a x minus 1 and a x plus 1. So I have everything factored. Now I'm going to start with my vertical asymptotes. So for vertical asymptotes, you're just going to take your bottom factors and set them equal to 0. That'll give me 1 and -1 as my vertical asymptotes. Then I want to do my horizontal asymptote or slant asymptote. I'm going to have here a horizontal asymptote. So how did I know that? Well, I look at the degree of the top and the degree of the bottom, and they have the exact same degree. The exact same degree. Okay, can I get this to, what happened there? Okay, there it goes away. So since the degree of the top, I'm going to call it f of x, is 2, which is the same as the degree of the bottom, I'm going to call that one g of x. Then there's a horizontal asymptote. At y equals, so we're going to take the leading coefficients. Take the ratio, 3 over 1. 3 over 1. In other words, at y equals 3 over 1 is 3. Okay, now we're going to go on to the, what do you call it? The x-intercepts, or the zeros, or the roots. So we're going to take our factors and set them equal to 0. So our first factor here on top, and blue, so we take our top factor, set them equal to 0. X. So that 3 out front is a constant. We're not going to, that's our leading coefficient. We're not going to use that. We're going to use x set it equal to 0. So one of them is at 0, and the other one we're going to take here x plus 4 and set that equal to 0 up top. And when we subtract 4 from both sides, we get a x-intercept at x equals -4. Okay, so for vertical asymptotes, you set your bottom factors equal to 0. For x-intercepts, you set your top factors equal to 0. And that should have been, I guess, a C rather than a B. Okay, now we want to do D here. So D, we're finding with the y-intercept. So for a y-intercept, we're going to set the x equal to 0, right? We're going to take y equals, I'm going to use the factored form, 3 times a blank plus 4 over blank minus 1 times a blank plus 1. So everywhere we have an x, we're going to plug in a 0. So 0, 0, 0, 0. So we're setting our x equal to 0. That's going to give us, let's see, y equals, so you take 3 times 0 times 4 over, let's see, negative 1 times 1 on bottom. Well, on top you're just going to have 0. On bottom you're going to have negative 1. So 0 divided by anything else is going to be 0. So y equals 0. You have a y-intercept. Okay. What else do we have? R of x equals 2 on top, and on bottom we're going to have x squared plus x minus 12. So notice that the top doesn't have any variables in it, but the bottom does, so we can factor the bottom. So I'm just going to copy down 2 on top. I'm going to factor the bottom into its 2 factors. So I want in the first parentheses an x, second parentheses an x. We've got to find 2 numbers that multiply to give negative 12 and add to give 1. So positive 4 and negative 3 multiply to give negative 12 and add to give 1. So now that I have everything factored, I can do the vertical asymptotes. I'm going to set my bottom factors equal to 0, x plus 4 equal to 0, x minus 3 equal to 0. The first one I can subtract 4 from both sides, get negative 4 for a vertical asymptote. And the second one I can add 3 to both sides and get x equals 3 as a vertical asymptote. So we have vertical asymptotes at negative 4 and positive 3. So can we find a horizontal asymptote or a slant asymptote? Well, here we're going to have, again, a horizontal asymptote. So if you look at the degree of the top here, notice you just have a constant up top, right? You have a constant. But you can imagine there being a x to the 0 power. So the top has a degree of 0. And the bottom has a degree of 2. So we're going to write that down. Since the degree of the top, let's call the top f of x, is 0, and that's less than the degree of the bottom, we'll call that g of x, which is 2. So the degree of the top is 0, the degree of the bottom is 2. The top's degree is smaller than the degree of the bottom. Then you're going to have a horizontal asymptote. Then there is a horizontal asymptote. Where is the question? Well, anytime the top has a smaller degree than the bottom, it's always at y equals 0. It's an important one to remember, at y equals 0. A really important one. Okay, let's go on to part C. X intercepts. So basically, if you look at the top, the only thing in the top is that 2. There aren't any linear factors in the top, right? There are no variable factors in the top. So since there are no variable factors in the top, no factors with variables in the top, that means you're not going to have any x-intercepts. No x-intercepts. Sometimes it happens. You never cross or touch the x-axis. You're never going to hit the x-axis, your graph. Okay, and finally part D, that's finding the y-intercept, if there is one. So we're going to set the x equal to 0. The x equal to 0. So I'm going to say y equals 2 over blank plus 4 times blank minus 3. So everywhere I have an x, I'm going to plug in a 0. So when I do that, I clean that up, I'm going to get 2 on top, and on bottom 4 times negative 3. In other words, 2 over negative 12, right? 4 times negative 3 is negative 12. So 2 over negative 12 is the same thing as minus 1 over 6. So we have a y-intercept at minus 1 over 6. What else can we do here? I'll do one more problem, I guess. Yeah, number 4. Let's do 3x squared minus 2x. No, let's not do that. That's fine. Minus 1 on top, okay. 3x squared minus 2x minus 1. And on bottom, let's say we have x plus 5. Good example. Now, first of all, before we do anything, we want to factor the top. And then factor the bottom. Well, the bottom's already factored. We don't have to worry about it. That is just one term down here, right? Just one term, x plus 5. So I'll just copy that down. But in the top, we can factor. Let's make 2 pairs of parentheses. And I'll put a 3x and a 3x in each parentheses. And then I'm going to find 2 numbers that multiply to give this product of 3 times negative 1, which is negative 3. So find 2 numbers that multiply to give negative 3 and add to give this middle number of negative 2. So those numbers are negative 3 and positive 1, right? Negative 3 times 1 is negative 3. Negative 3 plus 1 is negative 2. So I'm going to write a minus 3 and a plus 1 here. And then I have to do one more thing. I have to divide out anything in common. So in my first pair of parentheses, I have a 3 in common I can divide out. So in reality, r of x is equal to, so here the 3's cancel. I get x minus 1 times 3x plus 1 over top of this red, x plus 5. Okay? So that's the factored form. Now that factored form will be really useful for the factored form right here, which I'm going to circle in yellow if I can get it to right. That's useful for finding the asymptotes, the vertical asymptotes and the intercepts. Okay, so let's first find the vertical asymptotes. Isn't that the thing we usually do first? I think so. So we're going to take x plus 5. We're going to set that equal to 0, and we're going to solve for x. So I subtract 5 from both sides, I get negative 5 as a vertical asymptote. So just one vertical asymptote. Okay, then I go on to the horizontal asymptote, if I have one, or slant asymptote, if I have one. Do I have a horizontal asymptote? No. No horizontal asymptote. Since the degree of the top, I'll call the top f of x. So that's 2, and the degree of the bottom is simply 1. So it's bigger, right? The degree of the top is bigger than the degree of the bottom. The degree of the bottom, g of x, we'll call it, is only 1. So there's no horizontal asymptote, but there is a slant asymptote. Why is there a slant asymptote? Because the degree of the top is exactly 1 bigger than the degree of the bottom. So I'm going to chase a slant asymptote here. A slant asymptote. Okay. So I'm going to start off with my blue here that's not factored. 3x squared, well, let's put it up some. 3x squared minus 2x minus 1. Okay, and we're going to divide into the red bottom, x plus 5. Do long division. Okay, I'm going to call this, come on, where'd that go? Yellow x out front here. My question is, what times that yellow x gives me this 3x squared? Well, the answer to that is 3x. So I'm going to put a 3x up above the top there in the x column. Okay, now I'm going to take 3x and multiply it by the x out front, the yellow x, I get 3x squared. I'm going to take 3x and multiply it by the 5 out front. That's going to give me 15x. So now I'm going to subtract 3x squared minus yellow 3x squared cancels out. I'm going to take negative 2x in blue minus the 15x in yellow. I'm going to get minus 17x. Then I have a minus 1. Okay, let's get rid of this yellow arrow here. There we go. Now let's try to figure out what times that yellow x will give us a minus 17x. I'm going to say minus 17. Right? I take minus 17 and multiply it by x. I'm going to get a minus 17x. Okay, now let's take that minus 17 and multiply by that red 5. So what's minus 17 times that red 5? Well, I got to get a calculator for that one. 17 times 5. That's minus 85. So negative 17 times that red 5 is going to give me minus 85. Now I'm going to subtract here. So when I take negative 17 in blue minus a negative 17 in yellow, that cancels. When I take negative 1 minus a negative 85, that's the same thing as negative 1 plus 85. That's going to give me a positive 84 down here for a remainder. That's my remainder. Okay? So that means my function here, what's my function? I forgot what my function was. It was like r of x. Another way to write this function is to take the quotient up top. Come on, don't do that. Please don't do that. Take the quotient up top, which is 3x minus 17, write that down. And then take the remainder, which is positive 84, and put that over the divisor, x plus 5. So here's another way to write your function. And the horizontal asymptote, I'm sorry, the slant asymptote is going to be this part right here. The slant asymptote is going to be y equals 3x minus 17. That's my slant asymptote. All right. So we have a vertical asymptote at negative 5 for this function. We have not a horizontal asymptote, a slant asymptote of 3x minus 17. What else do we need to find? C. We need to find the x-intercepts. That's right. So to find the x-intercepts, you're going to take your factors on top here, the x minus 1 and the 3x plus 1, and set them equal to 0. So we're going to have x minus 1 equals 0. And the 3x plus 1 equals 0. Is that right? Yeah. So the first one, x minus 1 equals 0, we add 1 to both sides, we get x equals 1 is an x-intercept. The second one, we subtract a 1 from both sides, we get 3x equals negative 1. Divide both sides by 3. You get x equals minus 1/3 for an x-intercept. And finally, to find the, what are we going to find next? Y-intercept, okay. So we're going to go back to our function, and we're going to plug in 0 for x. So I'm going to use the factored version of our function. I like using that version for Y-intercepts. We got r of x equals, oh, hold up. We're going to call it y. Y equals, so we got x minus 1 on top, so blank minus 1. Also on top we have 3 times x plus 1, so I'm going to do 3 times blank plus 1. And then on bottom we have a blank plus 5, is it? Blank plus 5? Yeah, blank plus 5. So everywhere I have a blank, everywhere I had an x, I'm going to plug in a 0. See what happens. It's going to give me what? Negative 1 times 3 times 0 is 0, plus 1 is 1. And then on bottom, 0 plus 5 is 5. So I'm going to get negative 1 on top, 5 on bottom, so minus 1/5. That's my Y-intercept. Okay, I'll do one last example here of analyzing one of these rational functions, the number 5. Here we're going to have, let's see, minus 2, x minus 3 to the 3rd power, x plus 5. Then on bottom we're going to have, I don't know, 6 x plus 8 squared x plus 9 to the 3rd power, let's say. Okay? So this one's already in factored form, so thankfully it's already in factored form. That helps a lot when it's already in factored form for you. So I got my blue up top, I'll say, and my red down bottom. And we want to start by doing the vertical asymptotes. So for vertical asymptotes, you're just going to take your factors with variables in them and set them equal to 0. So I'm going to take x plus 8 equal to 0. We're going to disregard the exponents. X plus 9, set that equal to 0. And we're going to solve those. So the first one we're going to get negative 8 as a vertical asymptote. The second one we're going to get negative 9 as a vertical asymptote. Okay, now we want to find the horizontal or slant asymptotes. Turns out we're going to have a horizontal asymptote here. So let's look at the degree of the top. We're going to call the top f of x, since the degree of the top, f of x, is, so how do you find the degree of the top? Well, you take all the powers, all the various powers above the linear factors and add them up. So here we have a power of 3. This x plus 5 has a power of 1, so we're going to do 3 plus 1 is 4. So the top has a degree of 4. And the degree of the bottom, if you take the power of 2 here on bottom and the power of 3 here on bottom, you get a degree of 5. So the degree of the top is going to be smaller than the degree of the bottom, g of x. So since the degree of the top is 4, which is less than the degree of the bottom, which is 5, then there's a horizontal asymptote. At y equals what? Well, if the degree on top is smaller than the degree on bottom, it's going to be at y equals 0. Okay, now we want to do what's called the x-intercepts, if there are any. Well, you're going to take your top factors and set them equal to 0. So we're going to take x minus 3 equal to 0, and we're going to take, what, x plus 5 equal to 0. And we'll solve each of those. With the first one, we'll add 3 to both sides. We'll get x equals 3 as an x-intercept. The second one, we'll subtract 5, and we'll get x equals minus 5 as an x-intercept. Okay, finally, we want to find our y-intercept. And for that, we're just going to plug in 0 for the x's. So y equals negative 2 times blank minus 3 to the 3rd power. And then blank plus 5 to the 1 power, just blank plus 5. On bottom, we're going to have 6 times blank plus 8 squared, then blank plus 9 cubed. So I'm going to plug in zeros for my x's. I'm going to have a 0 here, a 0 here, a 0 here, and a 0 here. Now this is going to probably get really nasty. We got negative 2. We're going to have negative 3 to the 3rd power times 5. We're going to have 6 times 8 squared, and then 9 to the 3rd power. This is going to be really nasty. Negative 3 to the 3rd power. What's negative 3 to the 3rd power? It's negative 3 times negative 3 times negative 3. That's negative 81. And then times a 5. Then on bottom, we're going to have 6 times 8 squared is 64. 9 to the 3rd power is 729, right? It's 9 times 9 times 9 is 729. So on top, when I multiply, I'm going to get negative 2 times negative 81 times 5. So I get 810 on top. On bottom, I get 6 times 64 times 729. I get a nasty 279,936. And I believe you can actually reduce this sum. You don't have to reduce it, but if you want to, you can. Let's see, what can we divide out of the top and the bottom? I believe we can divide 162 out of the top and also out of the bottom. Both have a 162 in common. So if I divide 162 out of the top, 810 on top divided by 162 is going to give me simply 5. And on bottom, if I take 279,936 and I divide by 162, I get 1728. Yeah, so there's my y-intercept reduced. You don't have to reduce if you don't want to, but that's what it would be. 5 over 1,728. All right, so there we have it. There's analyzing a rational function. So our next section that we're going to do is section 4.3. We'll actually learn how to graph these. And there's